Hi, welcome back to BarnesBasics. We are looking at solubility and insolubility, specifically ionic reactions. And the next ionic reaction that we're going to look at is a combination of lithium sulfate mixed with ammonium sulfide to produce a couple of different products. We know that when we look at exchange reactions, typically the positive ion matches to the negative ion, so we're going to know that lithium sulfide would be one of the products, and ammonium sulfate would be the other one. Okay. With that in mind, we're going to go ahead and write out each individual compound and attempt to balance this formula before we continue with the ionic equation and the net ionic equation. When we look at a common oxidation number sheet, we know that lithium is +1 and sulfate is -2. By the way, I do need you to have already downloaded the common oxidation number sheet and the solubility rules sheet that I discussed in the first video of this playlist. That will make this experience very good. Ammonium sulfide. Ammonium is +1 and sulfide is -2. Lithium is +1 and sulfide is -2. Ammonium is NH4 +1 and sulfate is SO4 -2. So, to balance each individual formula, we have to make sure that the oxidation numbers are equal to 0. So it would take 2 lithiums to make +2 to cancel with that -2. This ammonium is +1. It's going to take 2 of these to cancel with that -2. +2. That will work fine. It's going to take 2 lithiums. 2 times +1 is +2 to cancel with this sulfide. And it's going to take 2 ammoniums. 2 times +1 is +2, and that will cancel with the -2. So when we look at balancing the equation, we have 2 lithiums, 1 sulfate, 1 sulfate, 2 ammoniums, 2 ammoniums, 1 sulfide, and 1 sulfide. So it looks like everything has been balanced at this point. The equation is balanced, and that's good. Good job. The next thing I want to do is I want to use the solubility rules sheet to determine which is soluble, which is insoluble. We're expecting one of these over here to be an insoluble precipitant so that we can have a net ionic reaction equation. So in our solubility rules sheet, rule number 4 says that all sulfates are soluble except barium, lead, calcium, and strontium. Well, that lithium is none of those. And so we're going to say this is soluble because of rule 4. Ammonium sulfide. We know that because of rule number 8, all salts of ammonium ions, potassium ions, and ammonium ions are soluble. So this is soluble, rule 8. Lithium sulfide. There is a sulfide rule. This is rule 7. All sulfides are insoluble except those of sodium, potassium, and ammonium. That's not sodium, potassium, or ammonium. Those of the alkaline earths, magnesium, calcium, strontium, and barium, are also soluble. This is insoluble. And we are going to invoke rule 7. Rule number 7. And then this one is actually soluble for a couple of different reasons. Number 1, it has ammonium in it, so it's soluble because of rule 8. And we also know that all sulfates are soluble except if it's barium, lead, calcium, or strontium. So we know that by rule 4, this one is also soluble. So this is going to be the ion that's precipitating lithium sulfide as a solid. And so that's kind of what we're aiming for. This is where we're heading from this point. But the next thing I want to do is I wanted to write the net ionic, I want to write the ionic equation before I write the net ionic equation. And I'm just going to drop down these ions and the numbers of them. So we're going to have 2 lithium ions, and that is an aqueous solution. We're going to have 1 sulfate ion, that is in aqueous or liquid solution. We are going to have 2 ammoniums in aqueous solution. We're going to have 1 sulfide, that is in aqueous solution. And this is going to yield the insoluble lithium sulfide. And then we're going to have 2 ammoniums in an aqueous solution, and then 1 sulfate in an aqueous solution. When we write the net ionic equation, we're only writing the ions that participated in this given reaction, which would be lithium and sulfide. So we're going to pick this one. We're going to say 2 lithium ions at +1 aqueous plus 1 sulfide aqueous is what gives us our net ionic equation. We say that the ions that do not participate are spectators. These are called spectators. Spectator ions are crossed out. So what really happens here is you might have a couple of solutions that are rather tame looking. Put these together and something drops out. It gets cloudy. And so that's what we have in this case. Lithium sulfide is the precipitant. Very good. Nice job, students.